Hey everyone, in this video we are going to solve the generate parenthesis question on Leetcode. The question says we are given a number n and we have to generate all combinations of well-found parentheses. So in this case we are given n equals to 3 and we have written all the valid combination with 3 opening and 3 closing pairs that we can generate. Well formed or valid parenthesis means as we write in code, so we cannot just write a closing bracket first always. So the closing bracket will always come after the opening bracket. So this is the question. Let's see how we can do it. Okay, so we have n equals to 3 here. So every valid combination will have 3 opening and 3 closing brackets. That much is clear. So every combination will have 3 opening and 3 closing brackets. Okay, so next, can we start from a closing bracket from the start? No, we cannot. That will be invalid. We must start from an opening bracket. So the other rule will be start from an opening bracket. Next, we'll have two choices from here. So we'll be using backtracking to solve this particular question. So we'll go through all the possible combinations and we'll check if they are valid or not, and we'll only add the valid ones and ignore the invalid ones. So from here on, we have two choices. We can either add two opening brackets, because remember we can add up to 3 opening and 3 closing brackets. So we have added 2 up to now. We can add up to 3 opening brackets. So this one is valid up to now. Next, can we add a closing bracket here? Yes, we can. So this is also a valid combination. From next step onwards, can we add a closing bracket, opening bracket here? Yes, we can. So there will be 3 opening brackets. Can we add a closing? Can we add a closing bracket here? Yes, we can. So 2 opening and 1 closing. From here onwards, can we add a opening bracket here? Yes, we can. That will be a valid combination. Now can we add a closing bracket here? So like this? No, that is not valid. That is not considered valid. So we can see another rule here is we can only add a closing bracket if number of closing brackets is less than number of opening brackets. So here number of opening brackets was 1, closing was 1, and we can only add closing bracket if number of closing brackets was less than number of opening brackets, but in this case they were both equals, so we can only add a opening bracket here. So moving forward, so can we add an opening bracket here? No, we cannot, because we have reached up to the limit n equals to 3. We have added 3 opening brackets. From here on we can only add a closing bracket for there. Okay, for this one we have again two choices. Can we add an opening bracket here? Yes, we can, because number of opening bracket is 2 up to now, so we can add another opening one. And can we add a closing bracket here? Yes, we can, because number of opening is 2, number of closing is 1, so another will be this one. Now here, can we add a opening bracket here? Yes, we can. So it will be, first option will be 2 opening. Another can we add a closing bracket here? Yes, we can, because number of opening brackets are 2 and closing is 1. So again we can add a closing bracket here as well. Now coming to the step, can we add a opening bracket to this one? No, we have reached the limit of n equals to 3. We can only add a closing one here. For this one, so can we add an opening bracket? No, we cannot, because we have reached the limit. We have 3 opening brackets, 1, 2 and 3. So we can only add a closing bracket here as well. So 2 opening, closing, opening, closing. Cool. So for this one, can we add an opening bracket here? Yes, we can, because we have 2 opening and 2 closing. So we can add another opening bracket here as well. Can we add a closing one here now? No, we cannot, because we can only add a closing one when number of closing bracket is less than open. In this case, it is equal. So will not add a closing bracket here. For this one, can we add a opening bracket? No, we cannot. We have reached the limit of 3. We can only add a closing bracket here as well. For this one, can we add a opening bracket? Yes. Can we add a closing bracket? No, because number of opening and closing are same. Now moving forward, can we add opening here? No, we can only add closing here. So this one is complete. We have added 3 opening and 3 closing brackets. Now for this one, can we add an open here? No, we cannot, because we have reached the limit of 3. We can only add closing here as well. So it will be like this. For this one, can we add a opening bracket here as well? No, because we have reached the limit 1, 2 and 3. We can only add a closing bracket here as well. So this will be it. For this one, can we add a opening bracket here? No, we have reached the limit again. We have 3 opening 1. So we can only add a closing bracket here as well. For this one, can we add a opening bracket here? No, we cannot. We can only add a closing bracket here as well. Okay. So as you can see, these 5 are the output that we'll be returning. So these all of them are 3 opening and 3 closing brackets. So we get all the possible combination for n equals to 3 by following these rules. We'll start from an opening bracket and we'll only add the closing bracket when the number of closing brackets is less than number of opening brackets. And the last one, when the number of opening brackets and the number of closing brackets is equal to 3, we'll push it to our output array. So the time complexity for this one will be 2 to the power n, and the space complexity will also be 2 to the power n, since we are storing all the combinations in an array as well. So that was the explanation. Let's see how we can do it in code. Okay, so let's first declare our variables. So our stack, in which we'll be adding our opening and closing brackets one by one. Another is our result array, which will contain all the valid combinations. Okay, next we'll define a backtrack function. It will take two things: number of open brackets and number of closing brackets. And at the end, we'll just call this backtrack function, passing 0 opening, passing 0 opening and 0 closing brackets. And at the end, we'll return the result array. So okay, so let's write this backtrack function now. So as per our rules, we can only push to our result array the combination to our result array when the number of opening and closing brackets is equal to 3. So we can write an if condition for that. If number of opening brackets is equal to number of closing brackets and open, or you can write close as well here. Open is equal to n. In that case, we'll push the stack, whatever is in our stack right now, the current combination, in our result array. So stack dot join full. So we join all the elements in our stack, create it as a string and push it to the result array. Next, can we add an open bracket? So we can only add an open bracket if number of opening brackets is less than n. If this condition is true, we can push an opening bracket in our stack and then call the backtracking function again. So backtrack, passing the number of open brackets plus 1, because we have added one more opening bracket to it, and closing bracket, add number of closing bracket as it is. And then once it's done, we'll pop the element from our stack. Now for the closing bracket, we can only add a closing bracket if number of closing brackets is less than number of opening brackets. If this condition is true, we'll push a closing bracket to our stack and then call our backtrack function again with opening brackets as it is and increasing the number of closing brackets by 1. And then again popping the element from a stack at the end. Cool. So let's run this. It's working. Let's submit it. Okay, cool. So that was it for this video. Thank you for watching.